So in the last video, I introduced the octet rule and talked a little bit about how electrons are assigned to these orbital shells that surround the nucleus of atoms. We also talked about the idea that all of the atoms that are out there want to have a full valence shell. So they want to have a full outermost shell. And the reason for that is how they are most stable. So I'm going to start this video actually with a question for you. I've drawn up some different atoms here. I want you to take a look at them and decide which of these are stable and which of these are not stable. So go ahead and pause your video really quick. And again, use what you've learned about the way that electrons are assigned and what's going on in the valence shell to predict which of these atoms will be stable and which will not. So when you turned your video off and you worked on this activity, if you said that neon was stable, you were absolutely correct. If you look at neon, it has 10 protons, so 10 electrons, which means that the outermost shell is going to have 8 electrons. It's full. That makes neon very, very stable. If you said that sodium and chlorine are both unstable, okay, and another way of saying that in chemistry is reactive, you were correct about that as well. So if we look at sodium, it has 3 orbital shells. Its valence shell, which is its outermost shell, has a single electron there. So this is going to make sodium very unstable. It's missing 7 electrons from its outermost shell in this particular format. What that means is sodium is going to be very likely to react with other molecules and have chemical reactions with other molecules. And in doing so, work to share or exchange electrons to fill out its outermost shell. If you look at chlorine, it has 17 protons, so 17 electrons. I've assigned them to their orbital shells, and you'll notice that its valence shell, so its outermost shell, is missing a couple of electrons. And if it could get an extra couple of electrons from somewhere, it would be most stable, in that most stable state and happy. So what I want to get into next is talking about how these atoms go about actually filling up their valence shells. So atoms are going to interact with other atoms to do this. When I say they interact, what I mean is they're having chemical reactions with each other, and that is causing them to form bonds. So that's causing them to actually become physically connected as they're sharing and exchanging electrons. So there's a few different bond types that we're going to talk about in this class. This first video is dedicated to what's known as an ionic bond, and then we'll have separate videos for nonpolar covalent bonds and polar covalent bonds as well. But when these atoms go about trying to fill up that outermost shell, they do so by interacting with other atoms, and by doing so they form a bond. If you look at sodium, it's not stable. It's what we call reactive in chemistry because its outermost shell, that valence shell, has just a single electron in it. It's not full. Chlorine is also reactive. It's unstable, again, because its valence shell, its outermost shell, is not full. The third shell, if you remember, can hold a total of 8 electrons, and chlorine has only 7 electrons in the outermost shell. It's missing 1. So both of these particular atoms want to interact with something else to exchange electrons with another atom in order to be able to fill up their outermost shells. And the way this actually happens is different than you might think. So I remember thinking when I was first learning chemistry, oh, sodium has like 1 electron in its outermost shell, so it needs to get 7 more electrons from somebody else. That's not actually what happens. What actually happens is if sodium can get rid of that 1 electron by giving it to someone else, this entire third shell just disappears. And when it disappears, it makes the second shell the valence shell. And that second shell is full, so that's going to make sodium stable. Often, okay, sodium will give up its electron to chlorine, forming sodium chloride, which is table salt, because chlorine is missing just a single electron in its outermost shell. And so if it gets an electron from sodium, it's going to fill it up. But now we've got something going on, okay? And here's an exception to that rule that atoms are neutral on their own. They don't have a charge. Over here with sodium, we still have 11 protons, so we still have 11 positive charges. However, we got rid of one of our negative charges. We got rid of an electron. So we now have 11 positive charges here, and we have only 10 negative charges. And what that does is it makes this atom so it has an overall positive charge, okay? And that's what an ion is. So an ion is an atom that has given up an electron or an atom that has taken an extra electron and it has become charged. When we look at what's going on with chlorine, so it took that electron from sodium, it now has a full outermost shell, but in this case we have 17 positive charges and we have 18 negative charges, and so the overall charge on this chlorine atom is going to be negative. It's also an ion. So whether it's positively charged or negatively charged, if an atom has given up electrons or taken on extra electrons, we refer to that as an ion. There are some subtypes of ions. So if we've got a negatively charged atom, like chlorine, it's known as an anion, and you'll see this written, so symbol for chlorine, okay, with a little negative symbol. You're gonna see that in your text, you're gonna see that as you're working your way through anatomy and physiology. If we go over here, we've got this positively charged ion, it's sodium. Positively charged ions are known as cations, and so sodium in this form is going to be written like that, okay? Na, its chemical symbol plus, to represent that we've lost an electron and now this is a positively charged cation. So after sodium gives up its electron to chlorine and it becomes positively charged and chlorine becomes negatively charged, now we've got these atoms in close proximity to each other with opposite charges. And you've probably heard the saying opposites attract, and that is true in chemistry as well. So we have a positively charged sodium and negatively charged chlorine, and they are going to actually bind to each other through a magnetic interaction, simply because one is positively charged and one is negatively charged. So this is what's known as an ionic bond. Ionic bonds form when you have one atom that has given its electron to another atom, and now you have oppositely charged ions, so a cation and an anion. In this case, the electrons are completely exchanged from one atom to the other. It completely gives it up. It doesn't get that electron back. So what we're going to do now is I'm going to give you another example to play with. I have an oxygen atom here and a magnesium atom here. I want you guys to look at what's going on in the valence shell and make some determinations about how these atoms are going to interact with each other. So one of these atoms is going to become an anion, one of them is going to become a cation. I want you to identify which one will be the anion and which one will be the cation. And previously, when we talked about sodium, I mentioned that when it takes, or when it gives up its electron, it's written like this, okay, sodium in the cation form, and chlorine, because it takes that electron, is written like that. So I want you to write out what magnesium looks like, what the charge on it is basically, and what the charge on oxygen is when it exchanges these electrons. So go ahead and pause your video now and take some time to do that. So hopefully you took a little bit of time to work through that activity, and if you did, you probably realize that magnesium has 2 electrons in its outermost shell, and if it gets rid of both of those, it's going to go down to only 2 shells and its valence shell will be full. So that's exactly what magnesium does. In this case, it actually gives up 2 electrons, which is perfect for oxygen because oxygen is actually 2 electrons short of a full valence shell. So when this happens, both of these atoms now have full valence shells. They're happy, they're in that stable conformation where atoms always want to be. The oxygen is going to become our anion, right? Because an anion is a negatively charged ion, and the oxygen has taken 2 extra electrons. Our magnesium is going to become our cation, so our positively charged ion, because it has given up 2 of its electrons. And if you were to see these written out, and you will see them sometimes in the book, you would see oxygen has a -2 charge and magnesium has a +2 charge, because in this case it was 2 electrons that were exchanged. But this is still an ionic bond. We have a negatively charged atom and a positively charged atom, and they now are going to interact with each other and kind of be held together by this magnetic attraction that they have due to the fact that opposites attract.